So now we will learn about robustness. So software is robust if it behaves reasonably even in circumstances that were not anticipated in the requirements specification. So it's actually if there is any exception raised during the execution of your software, then how your software is going to handle that exception. I think you guys are familiar with the concept of exception handling that you have learned in object-oriented programming. So if I give you a simple example, like suppose you have written a function that requires 3 parameters to call, but the user does not have that knowledge and the user is calling it with 2 parameters. So now your system should not crash. You should give a message, or there should be a message popped up saying that to call this function you need 3 parameters. So that's how you have handled that situation, that exception. So this is exception handling. So your software should be capable to work with malfunctions, to work with incorrect inputs. So that's robustness. So here in robustness versus correctness, software may be correct but not be robust. Yeah, if your correctness is all related with specifications, right? If you have good specifications, and correctness is only related with absence of errors, there is no errors, but robustness is related with errors. So if there is no absence of errors, you have given correct input and your software will give you correct output. So that's correctness, right? So in correctness it's not related with errors, but in robustness it's related with errors. So your software may be correct, you have given correct input, it's giving you correct output, so it's correct, but you did not even think about wrong data input, so you did not work on that. So that's why your software is not robust. And specific requirements, you have specific requirements, so that means if you fulfill those specific requirements, that's correctness. But robustness is actually working on those requirements that are unspecified, those requirements that were not listed. So if your software is capable of working on those unspecified requirements, then it's robust software. So the next thing is usability. So software is usable if its end users find it easy to use. We have already talked about this. It's the ease of using your software. So usability is an extremely subjective property, and it includes effort to learn, operate, prepare, input, and interpret the output of your software. So usability may be achieved through standard user interfaces. Okay, I can give you an example. Like think about the icon of the shopping cart. Okay, so if there is a standard icon of the shopping cart, and most of the e-commerce websites use that standard icon, but if you use a customized icon for your website, then it will take some time for the users to understand that that's the shopping cart. So if you use the standard one, you can achieve usability easily. So that's the thing. And the next one is usability refers to the human machine interface for non-embedded system. So what is non-embedded system? Non-embedded system is actually, you can say, mobile, laptops, desktops. So those are non-embedded system. So those softwares are actually written in high-level languages, and in this case usability is referring to the UIs, to the interface of your software. So that's usability refers to the human machine interface for non-embedded system. So for your mobile, if you write a software for your mobile, its usability will depend on the UI of that. software, but to the ease of configuring the software to the environment for embedded software system. So embedded software system, embedded system is like washing machine, or we can talk about dishwasher. So those are embedded system. So if you, these softwares are actually written in assembly languages. So here the usability will be how easy to configure the system to that environment. So the next quality over here is performance. We have already talked about it. We told that performance is from actually operational perspective, and software performance is required with efficiency. Software is efficient if it uses available resources economically. So performance is actually defining that how efficiently your software is using those resources, like memory uses or consumption of power, those kinds of things. And it's actually assessed by complexity analysis, measurements, model analysis, model simulation, those kinds of things. So suppose you have written an algorithm, okay? So that algorithm is embedded in your software, and it's a polynomial time algorithm. But the performance of polynomial time algorithm will be less than the performance of a linear time algorithm, right? So for increasing the performance of your software, you will try to develop a linear time algorithm for that purpose, and then the performance will be better for your software, right? So those are performance analysis. And performance affects usability. Yeah, of course, usability, you can think of user experience, right? We have just discussed in the previous slide what is usability. So now suppose your software is taking a long time to load a page, okay? So your web page is taking a long time to load the informations, and that's a negative user experience, right? That's a poor user experience. So if the performance is poor of your software, then it will directly affect the usability.